Hi, I'm Evan Levizade, and this is my 8-bit mixer kit. The first component of my mixer kit is an 8-bit digital to analog converter. So this is the same kind of thing that drives the speaker of your old Game Boy. This 8-pin 8-bit value that I'm sending determines the amplitude of this voltage here. So if I'm sending all ones, that's a decimal value of 255, and that determines a maximum voltage here. So I have 255 amplitudes that I can choose from, 256, one being 0. That gives me the ability to change the shape and frequency of the wave. I can make sinusoidal waves, sawtooth waves, triangle waves, and that all changes the sound you'll hear at the speaker. This is a op-amp voltage follower. It doesn't actually do any conversion, but it stabilizes the signal. The output of the digital analog converter circuit here is sent to this speaker here. Numbers 1 through 6 on the keypad determine the note that is played here. The next component of the mixer kit is an infrared proximity sensor. Here's a little circuit diagram. The transmitter is transmitting an invisible infrared signal, and it bounces off my hand and back into a receiver. And the intensity of the light from the transmitter to the receiver determines the output voltage here. The infrared proximity sensor seen here controls this speaker here. That as I move my hand closer to it, the frequency increases. Next feature of the mixer kit is a recorder. These LEDs will all simultaneously flash as a visual metronome, and then one LED will stay on as an indicator that the machine is recording one measure. So here's a playback. And you can play over the playback. And as you play over that playback, you can still use the single bit proximity sensor.